At the Bavarian State Library and the Munich Digitization Center, we're looking for ways to support collection development. In that context, we've recently experimented with link mining. I'd like to present our current approach, and as it is still a work in progress, I would be happy to hear your thoughts and suggestions. Our web archives consist of biannual selective crawls. Before we start crawling and archiving, we request the permission of the website owner. The websites are selected by subject experts at the library. One of these professionally curated collections is the Bavarica collection. It consists of all things Bavarian on the web and covers topics ranging from politics to sports to local history and literature. To give you a brief glimpse of the collection, I've selected some screenshots. So you can see here, for example, a website by an association dealing with local history, by a musical association, websites dedicated to famous Bavarian authors or to marginalized communities. We would like to assist our subject experts in finding new websites to add to the collection. One way of supporting collection development is focus crawling, where the crawler automatically assesses the relevance of the documents during crawling. Relevance may be measured by, for example, the frequency of certain keywords or the similarity to reference documents. It is, however, difficult to reconcile this approach with our permission-based approach. So we've looked for alternative strategies and come across the Web Art project in the Netherlands. The Web Art project mined web archives for information about the unarchived web. It specifically looked at links and anchor texts to build representations of these websites. We would like to adapt this approach and use this information to find suitable additions to our collection. We'll create representations not just from the anchor text, but from the text surrounding the anchor text, and we'll index this data to make it searchable by our subject experts. The first step is to extract the link context from the archived websites. We've defined the link context as the text content of the parent element. You can see here an example where you have the link tag and the anchor text that refers to a website about museums in Munich. And the parent element in this case is a paragraph tag, and it contains a sentence that describes in more detail the content of the website. This is an ideal example, but in reality, the link context is much more diverse. So you may have complete sentences, but also keywords, proper names, short acronyms, or identifiers. We tried to make the link context a bit more focused by excluding linked lists and adding a character limit. For our initial experiment, we've chosen the Bavarica crawls from the second half of 2018. It consists of captures of 117 websites. From these websites, we've extracted link information, namely the URL that is linked to, the host, the anchor text, the link context, and the inverse path depth. We've used the Archives Unleashed toolkit to extract the information, and we've filtered the links to remove intra-server links and exclude links to archived websites or content that is beyond the scope of our collection, such as social media content or news media. We've considered two different types of analysis, and the first is full text search with Apache Solr. This analysis currently is limited to German because that is the main language in our collection. The analysis steps typically include tokenization, stop word removal, splitting compound words, and stemming. And we've also included domain knowledge in the form of a taxonomy of Bavarian administrative units. This data can then be searched using Boolean queries. The second kind of analysis is semantic search with SentenceBird. SentenceBird is a neural network that maps sentences to vectors. These vectors aim to capture the meaning, the semantic content of the sentence, so that vectors for sentences that are similar in meaning are close to each other in the vector space. SentenceBird comes with several pre-trained models, and for our experiment we've selected a model that supports several different languages, including German, because web archive collections are often multilingual. In this case, you search using natural language queries. That is, you specify an example sentence and you compare the sentence embeddings to look for similar sentences in the link context. We've created a Jupyter notebook as a prototypical interface to demonstrate our results. For the full text search with Solr, you can enter your search terms here. I'd like to search for dialects in Bavaria, and you can mark them as obligatory or optional. We're then going to submit our query and get an overview over the number of results. We'll then display our results. So the results are grouped by host, and you see here a ranked list of the results. And for each host, you can click to see a more in-depth view of the results. So you can see here the link context that was returned. Here you can see the search terms that were matched, Bavarian, dialect, and here's the specific URL that was linked to. By clicking on this link, you'll be directed to the version on the live web. You can also look at the second result. Again, you see the different URLs. In this case, it's multiple URLs belonging to the same host that were linked to. Again, you see the link context, sentences. And in order to contrast this approach to search with semantic search using SentenceBird, we've chosen to re-rank the results of the previous search using the semantic similarity to an example sentence. So here you can specify your example sentence and compute the vector representation of your example sentence. So that's the vector according to SentenceBird. And now we'll re-rank our results according to semantic similarity and display them. So here you have the two rankings side by side. Here's the original ranking, and here the ranking by semantic similarity. The differences in color highlight differences in ranking. So this is intended to help you contrast and explore the two approaches to search. What have we learned so far? First of all, we found it necessary to integrate domain knowledge that is specific to our collection, and depending on the collection, that may be challenging to define. Secondly, we found that highlighting helps with evaluating the results because it makes it easier to detect false positives, for example, due to stemming errors. Unfortunately, the support for vector search in Solr is currently rather limited, but dense vector types and efficient search algorithms will be part of future releases, so that is something to look forward to. In general, the diversity of the link context limits usefulness of sentence embeddings, because, as I've said, the link context may consist of sentences, but also of acronyms or keywords. So it's challenging to define an example sentence that captures this diversity. Another open question is how to add a temporal dimension to the data, because up to now we've only looked at a single snapshot of a website, and we'd have to define how to aggregate link extracts from different captures of a website and how to filter them by time. And finally, we're also still thinking about how best to evaluate our results, whether to compute precision and recall on a small test set, or whether to conduct expert interviews with the subject experts that select the websites to get their feedback. So if you have any experience in that regard or thoughts on these questions, we'd be happy to hear from you.